Math, it's important. Math is everywhere. We use it every day. Learning math helps us think better. It helps us solve problems. Math is cool. Math is important for lots of jobs. You need math to be a scientist. You need math to be an engineer. You even need math to be a chef. Math helps us understand the world around us. So, let's learn some math. It's going to be fun.
All right, here we are. We're back again, and we're with a question. It's on fractions. All right, and as usual, this is a deep dive show, right? So we always go deep, and we like to go with the prerequisites, with the history, the behind the scenes as to why, right? So that's our style, and it really helps to know what's going on. I think it really enriches and encourages and enhance motivation for studying. Why are we doing these topics first? Why are we going so deep into them? Before further ado, let me welcome Teacher Rishika with me on this deep dive podcast on Maths Grade 5-6.
Hi guys, welcome.
All right, yeah, and um, the ministry, and I'm sure your education department, wherever you are, will be putting out statistics. How did the students how did the students do in the various areas and levels? And I almost guarantee that if you look across the globe from Singapore, and some of you would have heard of Singaporean math, considered one of the better mathematical approaches to dealing with problems. From Singapore to North America, with Canada, the US, and in the Caribbean, wherever you are, certain topics remain challenging for the majority of students. One such topic, one such concept, or series of topics under that concept would be fractions, right? And you'll hear about the different types of fractions and so on. But fractions at some level becomes challenging for students, and they start out very good and start to fluster with it, right? So let's go straight into a mock exam question, and then we'll head backwards into the history and the prerequisites and things you should consider to help you do better with fractions. All right. So let's see if we can pull this up here. Right. And this here is the question. Um, I have looked at it extensively. Teacher Rishika's looked at it extensively. But in case you're unable for some reason to go through the question, you listen to it in a podcast somewhere. Let me just read it out for you. This was a June 2024, grade 5, question 1B. Um, and it had three parts actually. I see two parts there, but it's three parts. And the statement is Brian shared a bag of mangoes with his friends. Friends, plural. He gave one third, I believe.
One fifth,
One
one
fifth,
fifth.
one fifth. Right? So now you have to read your question properly. Ensure you get your glasses when you go in if you don't see well. Um, one fifth to Henry, two thirds to Patsy, and the remainder. So somehow he gave away all his stuff, and you'd have to understand you give away all being the whole. And so when you add up your one fifth and your two thirds, you got to see the remainder, right? What fraction of mangoes was given to Henry and Patsy combined? This is a tricky one, right? Because the combined says it means you gotta do two things. You gotta find out for Henry, you gotta find out for Patsy, and then you gotta do something. What fraction of the mangoes did Samuel receive? And that is the remainder. And they said the remainder to Samuel. You have to find that. And then lastly, if Henry received, now here we move from fractions to quantity. If Henry received 20 mangoes, how many mangoes he had altogether? Now this question could have gone even further. How many mangoes did each person get? You know? So this is the question. And we're not going to look at the question just yet. We know it's a fraction. We know what it's asking for. But we're going to go back a little bit, all right, to see what's going on with what possible challenges or problems students will run into. And let me see if we can build this up before we actually start answering the question. All right, so let's take a look at let's take a look at the other what we should be looking at before we even touch the question. Teacher Ishika, you want to?
Yes, we want to look at how many persons where we saw friends there, so we know it's more than one. And we have two persons getting a fraction. We have Henry, 1/5, Patsy, 2/3. So that's the first thing we're going to look at. And we have to identify that these are fractions with unlike denominators. Now, combine would tell us that we have to add them. But a common thing with fractions, unlike denominators, you have to find like denominators before you can do anything else. And this will take us back to our multiples, prerequisite multiples, because to find our lowest common multiples, we have to list multiples of 5, multiples of 3. I would usually say the first 5, and if one, like 5 is our greatest number there, our greater number, our denominator, so we might get a higher number for 5, a lower number for 3. We will when we list multiples of 5. But I would tell my children, if you see that and you don't find a lowest common multiple, but usually you do within those 5. So if you list multiples of 3 and 5, you should find it within that 5 range. But if you don't, you go to your lowest denominator and you list a few more until you can compare and find a common one within those two.
Let me see if I can expand on some of the things you're saying actually. Because I recall when we were doing the sequences, and for those of you who haven't watched the sequences, the question on sequences, that was not a mock exam question. You stated that you would advise them to go to 10,
10, correct,
right?
correct.
And so for those of you who haven't seen that, you're probably lost. Like, wait a minute, 10, wait a minute, 5, right? So let's step back. When you're doing division, most of you don't know if you have like 16 divided by 4 and you're trying to do a long division thing. Now this should be fairly easy because this is your times table.
Tables.
But let me just, for argument's sake, say this is a challenging problem. 16 divided by 4 and you're doing a long division. Derivative approach would advise you from the inception to write down the multiples of 4. And you would have 4, you would have 8, you would have 12, you have 16, 20. And then you're like, oops, I see 16 there and then 16. And so by listing your multiples of these numbers, it makes it what's called a thing, man? Cheesecake or rice pudding. It make it easy, right?
Yes, it does. It does. It does make it easy. Now, some persons would go and they will multiply 5 by 3, and it will very well work out as your lowest common multiple in this case. But sometimes when we have some other numbers, what happens is that you end up with a big number, then you have to reduce. And one of the common mistakes, if this question is on a paper one question, and it is a higher order question, we have our knowledge based question, we have application, we have reasoning, and it's a higher order question. The answers for you to choose, it will be in its reduced terms. And if you just go and multiply, you would say, well, I don't see my answer there and I didn't do anything wrong, and you will choose the closest answer, which will be the wrong answer. So we want you to work with your smallest number possible first. So that is why you want to list those multiples. And you want to make sure that you choose the lowest common multiple. It must appear in your multiples of 5, and it must appear in your multiples of 3.
Let me cut in here because in this example doesn't really represent what you're trying to say, because in this case you said 3, 5 is 15, and 15 we know is the lowest.
Suppose we have 4 and 8,
That's the thing I was
and you
going
go and
to
you
say.
say 4 8s are 32.
But right.
That will not be
So
the lowest common multiple.
what would be the appropriate thing for you to start doing, what she's trying to say with your 5, is when you see 1/5, look at the multiples of 5, right? And why 5? We're looking at the denominator here again, right? When we're talking about multiples and lowest common multiples, we're talking about multiples of the denominator. So you should know this, but we still emphasizing the denominator.
Your denominators are your bottom numbers. Your bottom numbers are your denominators. Your bottom numbers.
5, 10,
so we want
15.
to make those bottom numbers equal. before we can add or before we can subtract.
Right. So you do 5, 10, 15, 20, 25, and so on. And then you go to the next denominator, would be 3. So you do 3, 6, 9, 12, 15, 18. And then you would notice two common numbers, right?
15
And there's a reason why they call it lowest common multiple. The
multiple.
common is they have similar numbers in their list
Same.
of multiples, right? And the lowest one, because if you keep going, you might find they have similar
More
numbers
than one.
higher, right? So you want to low the common and their multiples. So there's a reason why I call it LCM.
Yes, and the next common mistake, we were talking about 4 and 8 just now. And so your multiples of 4, you would start 4, 8, 12, 16, 20. Your multiples of 8, however, you will start with 8. 8, you're going to get 16. And what happens, sometimes persons don't look at that first number. They don't look at that first number, so they miss that 8. And so their lowest common multiple that they would choose would end up to be 16. So that is something to look for, right?
Maybe
Your
they're
lowest common multiple can be your first number
maybe they're thinking
for a
that
set.
the multiple has to be a big number beyond the number. It can't be the exact number. Say if you
Yes,
got
so
1, 8,
it
it can't
could
be
be.
8. They're saying it
So
can't be 8.
when we're listing multiples of numbers, it must start with the number itself.
Yep.
It must start with the number itself.
That's your times table there. 2 1s,
Correct.
2, same
Correct.
2.
Yes.
So multiples are your times table, people. Just in case you're missing that subtle point.
And when you hear the word multiples, multiply. Multiples,
Multiply.
multiply.
So now you have your multiples of 1/5. You have the multiples of 2/3, i.e. the denominators 5 and 3, right? You can see the common figure there, right? So it goes back to the point whereby you have to know your times table. You have to know what multiples are, right? And then you look for that. You have to practice find the common stuff. Now, it doesn't mean you can't find yourself using another multiple, but as the Jewish could have known earlier, if you use a higher multiple, there's going to come a point where you have to reduce. You're going to have to give yourself some extra work. You might not have the time. You might forget, right? You might leave your fraction in a high form and a non-reduced form. And I don't know, some cases might be wrong because sometimes they explicitly ask, give it
To
in its
reduce to its
reduced
lowest
form. If
terms.
you don't, then, that's a problem for you. You do all the hard work and you get all your marks. I don't know what to tell you. But that sounds like a waste of time to me. All right. So now we have now what we call, so we're going into a different territory now. We're going from multiples to equivalent, right? So we're going to make it equivalent now, and we're trying to make it an equivalent fraction here. You guys don't really know that's what you're doing when you do the denominator into the lowest common multiple multiply. You really see what you're doing is making equivalent fractions to add to subtract. Right? What do you say about that, Trishika? I don't know. That's how I see it.
Yes, we have to make them equivalent. You cannot add, well, some persons add very well, but it's wrong. So this is not basic addition as you were taught, just computing whole numbers. So we do have to make them equivalent fractions. So if you go and you put 1 plus 2 equals 3, 5 plus 3 equals 8, and your answer is 3/8, that is wrong. These are fractions. Fractions represents part of a whole, and we have to make them equivalent before we can add them.
And here's another
That's the
mistake.
most important
Here's
thing.
another mistake you'll make, and you probably might see this in one of the multiple choice answers, and you might say, "Yeah, but I see it there. It has to be right." You might make the mistake of saying, "Okay, 1 plus 2 is 3," and then you put over 15s. You might see 3 15s.
Correct, and that there is incorrect also. So some persons would do that. Some persons will let's say they had 2/10 or 3/10. Some persons would look at 5 and 10 and they would say, well, 5 and 10, they're related. I'll just put the lowest number there, and the lowest number is 5. But that is not the lowest common multiple.
So these are all the errors, and believe you me, it shows up. A lot of you mistakenly. I don't know if you just didn't understand or at that time you're
So
under
first
pressure.
thing, and that is why with maths, we want to follow the rules. We want to follow the steps. They're important. So if we say to list the multiples first, please list the multiples first. Don't do your own thing, because if you go to any other country to live, maths remain the same. The rules of maths, they are the same. It doesn't change like a language.
So now we have 1/5 and 2/3. And if we were to make them equivalent fractions, you'd have to turn 1/5 5 to 15. And if you do it The rule is if you do it for the denominator, you have to do the exact thing
For
for
the
the
numerator.
numerator, which is the top number. So if you multiply 5 to get 15, whatever that number is you multiply by, you have to multiply that same number by the numerator. So 3 5s are 15, we know. Hence, the numerator becomes 3 times 1. So it becomes so 1/5 is really 3/15. So that's the equivalent. All right. And then 2/3, 5 3s are 15. So 5 to the 10. So then 2/3 become 10/15. All right. Now, you don't like the equivalent approach. It sounds strange to you because you were told you find the LCM and then you divide, multiply, and so on and so on, and you lay it out. So what you would have is a 1 LCM for both fractions on 15. And then you would say 3 into 15, 5, 5 ones 5, and and 5 into 15, 3, 3, whatever the case may be. And then you see you have those two numbers at the top of a long line with one single denominator. That's okay. Really and truly, it's the same thing
Same
you're doing,
equivalency, yes.
right? But
But
it looks different.
I want to point out something else. So we have 2/3, right? Now we have 2/3 and we have 1/5. And because the first one was 1 and you just multiply by 3 and you get 3, what persons would do, they would assume that is 1 on top of the 3 also that they have. So they would just go and put, they would very well divide, but they would not multiply by that 2. They'll just put 3 into 15, 5, and they end up with 5 over 15.
Oh,
And
really? So
yes,
they go halfway
so
then.
well,
They don't even finish off the multiplication.
somehow, right? Because they would have seen 1, or sometimes in fraction, you start with 1 over 5, 1 over 3. They assume everything is 1. So whatever they divide and get, that is the same thing. They don't go to multiply by 2 or 3. And so we have to be very careful with that. And that's why it's important to put pen to paper. And we want to see things. We want to be very, very observant and diligent with the math. Because in some cases, it is not that you don't know, it is that you're not paying keen attention to what you're doing. So they will very well have that 2 times that 5 there, but they're going to put 5 because they're just thinking that in the first step they did 1 and they have 3 there because 5 into 15, 3. And so they do the same thing, 3 into 15, 5, and they just put the 5 without using their numerator. And I would say that you have to account for all of your numbers. You have to account for all of your numbers and the value of your numbers. Do not assume that it is 1. If you have 2 there, make sure you use your 2.
All right. So we're answering the question, but we aren't focusing on the questions below. We're just trying to pull out the numbers from the statement. We're just trying to make sense of it. And so far we know we have three 15s and 10
10.
15s. So 3 15s and 10 15s, right? So if we have 3 15s, 10 15s, we know that adds up right away to 13 15s. And hence, to make a whole,
Oh, please don't go and add the 15 and 15 and get 30.
oh my goodness,
Don't
that's
add the
another
2
one.
numbers at the bottom because you're adding at the top, because we would have said same thing you do at the top, same thing you do at the bottom.
Oh,
Once we would have made those fractions equivalent,
right.
we can now add them because they have the same denominator. So we do not need to add the denominators when they are the same. So we have to make them the same. We must make them the same to add and subtract them, right? But once they're the same, we just put them back. We don't do anything to them. We put them back and then we go ahead and add our numerators.
Let me see if I can put that in a different way. The numerator, the top numbers, represent the pieces which we're dealing with. The pieces of the pie, the pieces of money, the number of mangoes, the pieces. And so it's the pieces we're adding. The denominator reflect
The
how the
whole.
whole and how much the whole was divided into or shared into or separated into in the first instance. So our focus really is to add the numerators, but we really can't add the numerators just yet until they're balanced. And to do that, the denominators have to be balanced, really. So it's a little tricky, and fractions are complex. I know it's easy when you add 1 and 2 numbers. When it comes to fractions, they're parts, and you have to treat the parts as the rules have been taught to you. So now we have 13 15s, And clearly, for those of you who don't know, a whole is the same number in the numerator and the same number in the denominator. So 15 15 is one whole. 100 over 100, one whole. 1 over 1, one whole. 4 over 4, one whole. So therefore, one whole in this case, since the denominator is 15, one whole will be 15 fifteenths, right? So if we have 13 fifteenths, right? It means how much more do you add from to 13 to get 15? Two more. So the remainder right there and then, without us doing any calculation, you should be able to see it, is 2/15, right? So let's get to the question. Let's get to the question, Teacher Ishiko. We have the first question here. What fraction of mangoes was given to Henry and Patsy combined? I think we've almost done that.
Yes, because we would have worked out the equivalency. 3 over 15 plus 10 over 15 will give us 13 over 15.
So the answer there, 13 over 15. Now the thing is, those of you who can't remember your prime numbers and your odd numbers and all these things, that's why you were taught them in the first instance. Because if you know prime numbers, you can't divide other than the one and the number. And then the rules for odd numbers and so forth. Why is that important? Right now, if you have 13 15s, you can't reduce it. That's it. That's the final, right? Let's go on to the next question, Tricia. What fraction of mangoes did Samuel receive? And it says in the statement that he got the remainder.
Yes, it says son and the remainder to Samuel. Now we would have just said before we started this question that if your denominator is out of 15, that is how much parts we have, or that is what the whole is out of. So the whole, one whole, will be equal to 15 over 15. So we know that 13 parts were given to Patsy and Henry. So what remains? 15 over 15, our whole. Take away 13 over 15 leaves us with 2 over 15.
So you have to show in this is a paper 2, mind you. This is not a paper 1 where you select A, B, C, or D. It's a paper 2. So you might want to show your working either in the strip, the section for your working or your explanation or whatever the case may be. You might put 15 over 15 minus 13 over 15 and so on. In some instances, you might be required, depending, yeah, look at the space and the marks, you might be required to go a step further and say Henry and Patsy together receive 13 over 15. Therefore, the remainder to Sam, you have to, lay it out like that. All right. And I know some schools teach that you really
Yes,
have to
yes.
lay things out in fine detail. You use your therefore and your and if and so forth, right? So ensure you look at the question, the marks, the space given. Sometimes they have a small line for you to put the answer, but most times I would encourage you always show your working, whether you think they want or not, because somebody has to mark it, right? And I can tell you, as a matter of secret, yes, yes. Sometimes when people marking and they look, if you make a mistake and they look and see you're working, they kind of, no, yeah. All right. So here we go. We have part 1 answered. We have part 2 answered. Now we're going to the last part. If Henry received 20, so we gone from fractions now to quantity, and this is where some students get thrown off. If Henry received 20 mangoes, how many mangoes were in the bag? Now let's go back. What fraction Henry had in the first instance? You want to take
One,
that, Jushi?
all right, so Henry had 1/5. Important to note that we're looking at Henry alone. So we're saying, or the question is saying 1/5 is equal to 20. So 1/5 is equal to 20. So we're not going back to that 15. We're finished with those 15. We're looking at Henry alone. So 1/5 is equal to 20. So it means that one part is equal to 20.
And then it should be fairly simple. But obviously it's not that simple. It should be simple
So
if one part equals 20.
in this case, the whole is 5. The whole
Right.
is 5 in this case.
5 parts.
So 5 parts. You don't want to go back to that 15 because for this question, the focus is on Henry. The focus is on Henry. We usually tell the children that the questions are related, and yes, they're related, but they are related to that stem. The stem says Brian shared a bag of mangoes with his friends. he gave 1/5 to Henry. So all these questions are related to that stem. So don't get confused and say, well, we're just doing 15. Now, how is 20 mangoes? Some people might go and add 20 plus 15, because those are the only numbers they know, or they might go and add 13 to 20. So you want to be careful with your reading. It says Henry. So we go at the top and we find Henry, 1/5. Henry gets 1/5, and 1/5 is equal to 20. So one part is equal to 20. The whole thing was out of 5 because we said that the denominator, tells us how many parts this thing was shared into, how many parts. So 1/5, so 5 times 20. 5 times 20 is going to give us that whole. I know some people, they go and they add for everything. Everything is addition or subtraction. But when you're doing fractions, it is more than just addition and subtraction. We actually have to work it out, right?
But here again, you got your answer. Let's assume you don't know your times table. You're struggling to multiply 20 by 5. You can't get that 100 in your mind. You know, um, when you're finished, you're done the question. You move on. You got some extra time. You got 5 minutes, 10 minutes remaining. You should be doing some revision, some looking over, some looking back, some checking over. Some persons do it immediately after the problem. Others go through all the problems and come back. Some persons do both, right? But let's play with this a little bit, right? Because 1/5 is supposed to be 20, 2/3 supposed to be something, and the remainder is supposed to be something, right? All right. So when we were doing the equivalent, and I think we got from 1/5 we got three fifteenths. So 3/15 would be 20, right? Now the reason why we didn't want to do the 3/15 equal to 20, how much would 10/15 be? Is because 15 and 20 and these numbers, they can run you in some extra work. Those of you who are comfortable, go right ahead, right? But when we made 2/3 equivalent to 1/5, we found out 2/3 was 10/15, right? Can we reduce 10/15, right? If was it two, was it what, three the three if 3/15 is 20, what would 1/15 be, right? Then you have to divide the 20 by 3, I believe, right? And then there's when you get a decimal, and this is the complication, right? So some of you might want to go around the route if you're very good with decimal, but there's a reason why Jurishika is saying let's go back to the stem or the question statement and let's deal with these simple fractions. All right? And so you're doing a revision. You can go through that lengthy process of equating the 15s and so on, or you can just look at what you have here, look at the fractions, and see if they add up in the quantity. But the beautiful thing about this question, it doesn't ask you to look at any other person. It doesn't ask. It could have asked you how much Patsy got as well, or how much whatever the case may be, right? But it did not, right? Just ask all together. How many mangoes were there all together? Now, this very question could have been enhanced or made a little bit more complicated in so many ways, right? But the bottom line is when you see a question like this, try to look at the keywords. And the keywords in this case were remainder for Samuel. That's one, remainder, right? The keywords were he gave it to his friends. Now, some of you, as Situation was talking, it came to my mind. Some of you might think, well, hold up. Brian gave away everything and you keep none for yourself, or fraction you keep for yourself. And that might throw you off, it might stumble you a little bit as to, wait, a fraction missing here. Yes, sometimes in these mathematical problems, somebody gives away everything they got. Right? In the real world, you might want to keep something for yourself. So don't let body. They say you share the bag, right? Maybe you got another bag home for himself, right? Don't let them simple things confuse you. Read the question as is, all right? And work along that line. All right, what else can we say about this question, Jurishika? There's a fraction. This seemed like a very fairly simple stage by stage,
Well,
level by level
yes,
fraction.
yes, it's simple when you know it. And as I say, and when you pay attention to your keywords, it is simple. But you know, for fractions, we have to go back to the basics to know our multiples, to add properly, equate properly, make equivalent fractions. All those are things we do before we go to addition of fractions. Just careful reading and working out of your problems.
All right. So thank you for joining us on a deep dive. And the question is there, the answers discussed, the prerequisites, and we'll see you guys.
And we also have Deep Dive also have their Deep Dive fraction app. So
I
yes,
forgot to do that.
you can also check that out.
In fact, I think
Everything
we should do a session on that.
everything in stages from the beginning to the end. I'm sure once you use that app, you start using it, it will give you a deeper understanding
And if I
into fractions. If you don't know anything about fractions, that's also going
That
to
is
help
correct.
you,
That is correct. Because if I
right?
remember correctly, it
So
was so designed to help people from scratch, from the
yes,
bottom.
yes. So we're not only, sometimes we want to help people go that extra mile, but we're focusing on those who don't know, who want to know, who's struggling in some area, and refreshers for those who already know. Maybe you get a little bit of refresher. So check out our fraction app that we have there, Deep Dive.
So it really has from the beginning where you practice. You're actually clicking. You're not reading. That's a beautiful thing. You're clicking here, and you're starting from what is the numerator, what is the denominator. How you click and you see how it changes fractions, how it changes quantities, and goes straight up to you applying the app to questions in the mock exam as well as other standardized exams. Okay, so check our website. Everything is on the screen there, and take care. Bye bye. Thank you for joining us.